Okay, so first things first, this is not Ohm's law. To calculate, it's just a formula for calculating the resistance. If you knew what the resistance was, you could rearrange it using this triangle to work out the current or the voltage. It's not Ohm's law. I'll explain what Ohm's law is in a moment. Just briefly then, what is resistance? Well, in basic terms, we can say it's a measure of how much it slows down the current. More specifically, we can say it is the voltage necessary to produce a current of 1 amp, because it's the voltage per current. Now, what is Ohm's law then? If this isn't Ohm's law, what is it? Ohm's law, let's write it down. So Ohm's law states that the current is directly proportional to the voltage. Directly proportional, that means, so in other words, if the voltage doubled, the current would double.
Yeah.
So you're going to have, so if something follows Ohm's law, not everything follows Ohm's law. It's kind of, again, it's a bit of a weird way of saying it, because we would imagine that a law is dictating how things behave. But it's not. It's actually dictating how things behave that follow the law. So it's a kind of a bit of a weird way of saying it. So we would have a graph like that if something followed Ohm's law, where that could be the voltage and that could be the current. So, but a light bulb does not follow Ohm's law. However, you can still use this formula. What we would say is, if something follows Ohm's law, the resistance of and we can call them ohmic conductors. These are components that follow Ohm's law. Resistance of an ohmic conductor, I should say, has a constant resistance. Is constant.
Yeah.
Whereas for, let's say, for different voltages, whereas this is not. Okay, the resistance changes. Okay, all right, I will stop the video there.